Okay, so this one is Spring 20, Exam 2, Dynamics, problem number 4. So we have a 30 kilogram box that's being pushed up an inclined plane. And the kinetic, so we have friction. And we have the velocity at the bottom of the ramp is equal to 0. And we have that the ramp is 14 meters high. So we want to determine the acceleration of the box up the ramp, the velocity when the box hits the top of the ramp. So you know, again, I need acceleration or velocity. If I'm using acceleration, it's just going to be sum of forces equals mass times acceleration up the box. If I'm doing this, it's going to be 1/2 mv squared plus sum of force distances equals 1/2 mv squared. So I'd have to make sure I keep up with all of my distances, and it doesn't matter which way you want to work this. So again, as with always, you first have to draw a free body diagram. So if I've got a 20-degree ramp, then my box is going up. This is 20 degrees. So if I have a box on here, my direction is in the x direction. We always do that. So y is coming perpendicular. So I have that normal force. I have, if I'm pushing up, I have this force of friction, which is 0.18 times normal. Okay, I have gravity pulling down, and it's a 30 kilogram box times 9.81, because this is my force side. And then I have this force F. So when I look at this force F over here, if we have from X up, okay, then I can also see this is parallel. So we have parallel surfaces. If this is 20, this has to be 20. Okay. So when I'm looking at my force, then I'm going to have a force of sine cosine 20. And that means I've got a force sine 20 that's coming down. And I'll need to go back and look up here. But if I'm going, when I'm looking at this, if I'm going from the x major to the x prime, 20 degrees, I'm going from the y major to the y prime, this also has to be 20 degrees. So if I have this force coming down at 30 times 9.8, 30 times 9.8, okay, then it's got to have an x component and a y component. And if this is 20, then the x component is sine, so this is going to be sine 20, and this y component is cosine 20. So that's what that is. Okay. So now we have to start looking at the whole situation here. So either way I go, I'm going to have to figure out what normal force is, and so I'm always going to have summing force in the normal direction, which is in that y direction. Okay, it's not normal in terms of we are spinning in a circle. We'll go back and call that y. Okay, but it is in this direction. I know that that equals 0 because the box is not moving in this direction. The box is moving in the x direction, and that's why if we make the direction we're moving the x, then I know that the y direction has to be 0. So if I look at this, then this way, okay, this way right here is positive, so I'm pushing down, so I have a negative f sine 20, okay, and when I look at my force of gravity, that force of gravity, okay, we have minus 30 times 9.81 times cosine 20, okay, plus we have that normal force. So we're looking at everything. Let me get a different color. Maybe that will help. Okay, we're looking at everything in this. This is my y direction. So I have the y component of this. So there's that y component of this. I have the y component of my force. And then I have that normal force that's coming up. and I don't see anything else in that direction, equals, and I know this equals 0 because again there's no motion in that y direction. So let's pull this out, and I get, so F was 275, so negative 275, enter, and then I'm going to multiply that by a sine 20, and then I have this negative 30, that's my kilograms, so mass G, I have to multiply by 9.81, okay, and it's not the full amount, but it is 20 degrees cosine. Okay, those are both negative, and I'm going to add them, so they're negative, and then I'm going to push them over here, so I can find that my normal force is 300, let's check our math again, so I have, is that 275 for my, okay, so 275, enter, and then I have sine 20, okay, and then I have the mass of my box is 30, enter, 9.81 times, whoops, that's still not right, 30, enter, 9.81 times, and then I have 20 cosine times, plus, and I get 370.6 newtons. Okay, so 275, enter, 20 sine, 30, enter, 9.81 times cosine, whoops, 20 cosine times 275, enter, 20 sine times 30, enter, 9.81 times cosine 20 times plus. Okay, so 370.6 newtons. Okay, so that is this force that's pushing back up here. Now I know if my normal force is 370.6, that my force of friction is 0.18 times 370. Okay, so now if I continue with, I'm going to sum my forces in the x direction. That's going up my plane. It equals mass times acceleration up my plane. If I look at all my forces in the x direction, let me find a different color now. How about a red pen? If I look in the x direction, so we're wanting to go this way as positive, I have force cosine 20. And I have friction that's going backwards. And when I look at this mess, I can see that we are actually going in that direction. So I think that's all the forces that I have. I have the force of gravity on my mass, I have the force pushing up, and I have friction. So we are going to have F, which is 275 newtons times cosine 20, okay, minus that force of friction. So I have 370.6 times 0.18, okay, minus, and then I have the force that is gravity pulling it back this way. So I have minus 150 sine, I don't know where I'm coming up with the 150 today. That's the weirdest thing ever. Weirdest thing ever. Minus 30 times 9.81 times sine 20, and that equals mass times acceleration up the block. And keep in mind, we were given mass. That mass is 30 kilograms. So let's work this out. So I have 275 enter, 20 cosine times. I have 370.6 change sign enter, 0.18 times. I have 30 change sign enter, 9.81 times 20 sine times, plus my two negatives, plus that 268 up the ramp. And then we're going to divide through by 30. That's our mass. And I get my acceleration up the ramp is 3.035. And we are working with meters per second squared. Okay, so that is the acceleration as I'm moving up the ramp. Okay. I also know that I'm starting here at 0. And I'm moving, well, the height is 14 and this is 20, so sine, that's so. So I do know that sine of 20 equals opposite over hypotenuse. So opposite over hypotenuse. And hypotenuse is that length of the ramp. So we have sine 20 equals 14 over hypotenuse. Not hypotenuse, height. I should have called, oh, I guess this is the hypotenuse. I shouldn't have called that height. That's kind of weird. So the height, the hypotenuse, the length of my path is going to be 14 divided by sine 20. And I get 40.93 meters. So if this is 14 tall, the length of this ramp is 40.93 meters. Okay, so that would be the length. So now if I want the velocity when it hits the top of the ramp, well, I know that velocity equals v naught plus at. I know my acceleration and my initial velocity, but I don't know time or final velocity. I know that s equals s naught plus v naught t plus 1/2 at squared. I know acceleration, I know velocity, I know s, and I know my ending position is 40.93 feet, but then I have to deal with a square. And I also know that v squared equals v naught squared plus a plus 2a s minus s. And I've got this covered, I've got this covered, I've got this covered, so I can calculate velocity. I can calculate time, and then I can check it by using this equation. So let's start here with v squared. So v squared equals 0 plus 2 times 3.035 meters per second times 40.93 meters. And I get that v squared equals 2 enter 3.035 times 40.93 times, now I have to square root that, 15.76, so I went ahead and square rooted it, meters per second. So that would be my velocity at the top of the ramp. And I can look at this one, and I have 40.93, that's my final, equals 0 plus 1/2 a 3.035 t squared. So I have 40.93 enter times 2 divided by 3.035 divided by, okay, and now then I need to take the square root, and I have that my time it takes is 5.19 seconds. So I should be able to fill everything into this and make sure it holds true. So I have 15.76 equals 0 plus 3.035 times 5.19. So I should have 3.035 times 15 that it equals. So it works in all of my equations. So when I come back here, I have the acceleration up the ramp is 3.035. The velocity when the box hits the top of the ramp, velocity equals 15.76. The time it takes for me to go up the ramp is 5.19 seconds. Meters per second squared. And now the rest of this is kinematics. Okay, so I'll make another video with the kinematics. So if you are not struggling with kinematics, you're great. If you are struggling with kinematics, you can watch part 2 of this video.